Hello, and welcome to this Richardson RFPD and Kyocera AVX webinar. With us is Carmen Rondado. Carmen is the Global Marketing Manager of Antennas at Kyocera AVX.
Thank you, Katie. Good morning or good afternoon, everyone, and welcome to this webinar called 5G Antenna Solutions for Today and the Future. So let's start reviewing what is 5G. And this is a term that has been used for years, and it can have different meanings depending on the application. What is clear is that 5G has been designed to meet the very large growth in data and connectivity in today's society and the tomorrow, and it's created to solve the matters that we are having more connected devices, we have more real-time applications, and they have more information transmitted, which is in result of higher capacity and higher speed. So if we look at the technical side, what does it mean? Here are some specification requirements of 5G. So from the network side, we are aiming for 99.99% availability, 100% coverage, and 90% reduction in the network energy usage. Then on the device side, we are aiming for, in some applications, up to 10-year battery life, which is very outstanding compared to the current technologies, where you have to charge your devices almost like every day. And this is using by the IoT low power WAN technologies. Then we are aiming for 1 millisecond latency. So latency is the time to connect, interoperate between two devices. So 1 millisecond latency will mean almost like real-time connectivity. More than 1,000 times the bandwidth per unit area, and 100 times more devices connected compared to the 4G, and up to 10 gigabits per rate, which is 10 to 100 times improvement compared to the 4G. So these are all the requirements that we are looking at to be able to overcome the features I was mentioning before. So if we compare this 5G with the 4G, we are going to look at the main differences. So the main differences, as we said before, is the latency. So in 4G, in the current 4G networks, we have 10 milliseconds latency, while in the 5G, we're aiming for less than 1 millisecond latency. The speed, the data rate in the 4G is up to 1 gigabit per second, while in 5G, we are having up to 10 gigabits per second. The spectrum available is much larger. In 4G, we only have 3 gigahertz the spectrum, when in 5G covers up to 30 gigahertz. And of course, the number of connections. In 4G, we have 100,000 connections per square kilometer, while in the 5G, we have up to 1 million connections per square kilometer. So until the 5G is fully deployed, the 4G is going to coexist together with the 5G. And this is something we need to have into account also when we look into the antennas. So let's look into the antennas now, comparing the 4G and 5G. What are the main differences? And here what we are comparing is the sub-6 gigahertz antennas between 4G and 5G. The first difference is the frequency band. We said before the spectrum is larger. So in 4G, we are covering between 700 megahertz up to 2.7 gigahertz. In 5G, we are covering all the 4G bands, because we have in the coexistence, and many of the 5G bands are also the same frequencies as the 4G. And in addition, we are adding the new bands for the 5G sub-6 gigahertz, which are one and the 600 megahertz or the 3.3 to 5 gigahertz band. The bandwidth is also different, the channel bandwidth. So in 4G, without carrier aggregation, the bandwidth of the channel is 20 megahertz, while in 5G it's 100 megahertz, so it's much larger bandwidth that needs to be covered at once per channel. The number of antennas. In 4G, you could have 1 or 2 antennas. So if you have 2 antennas, you have normally one of them is the main antenna, while the other one is used in diversity, which means that you are transmitting with one antenna, and you're receiving with two of them. In 5G, there is MIMO. MIMO normally is 4x4 in the device side. And when you say MIMO, one of the differences is that you are also having MIMO transmitting. So in 4G, you have two antennas receiving, but only one transmitting. In the 5G, you have four antennas receiving, but normally, like nowadays, like two antennas transmitting. The signal processing. So in 4G, as we mentioned, we have the possibility to have diversity, while in the 5G, with the MIMO, we have the possibility to have beamforming. So beamforming is that we are changing the phase of the antenna, and we are changing the gain, the direction of the gain of the antenna. And finally, the SAR. The SAR is the specific absorption rate that in the past it has been critical, especially for wearables or handheld devices, because it's absorption by the human body. This has been solved with the years with techniques of placing the antenna in the bottom of the phones, etc. Now, with the 5G, since we are going to have more than one antenna transmitting, it might become critical again. So this is something that we also need to consider when designing antenna. So in conclusion, we have more antennas, we have more transmitting antennas, more bandwidth. So it's very important, two main factors. One is the isolation between the antennas, and also is the full antenna system design. So it's very important. It's not antenna per antenna, but you need to evaluate the whole system to have a good 5G performance. If we look at applications, so as I was saying in the first slide, that 5G could have different meanings. This is what I mean. So with this, if we look at the different properties of the 5G, we can divide it in three main features. One of them is the massive IoT, massive Internet of Things, enhanced mobile broadband, and mission critical communication. So the massive IoT is what we're talking about, having more data, more devices connected. You want to have low battery life and have longer coverage. Then when you look at the enhanced mobile broadband is where we are looking at higher capacity, higher speed. And then the mission critical communications in focus on the ultra low latency. So depending on the application you are looking at, you will see in what part of this triangle your device will be placed. So if we look at the massive IoT, so you can have smart cities, industrial applications, agriculture, when you have several connected devices. This is the kind of billions of devices will be connected, so you will be more focused on this side of the triangle. If you're looking at the enhanced mobile broadband, there will be applications like outdoor broadcasting applications when they are connected to the cloud. You have a fixed wireless internet at home where you want to have very high speed. So all that, especially now with the well-known now the topic of metaverse, so all that we will need very high rates of speed. So all that will be in the mobile broadband. And then the low latency is also related to the metaverse, because all the applications that are cloud-based will need to have a ultra low latency to be able to have real-time sense. So you have these cloud-based applications, autonomous cars, healthcare, all these, and the smart factory. So all these applications will need very low latency. So there are applications like gaming, smart homes, that you will see that they are in between two things, between high speed and critical communications, or the smart home, which is a mix between IoT and mobile broadband. So we look at the spectrum. We can divide in two parts. So we have the sub-gigahertz bands, which are all the bands below 6 gigahertz. And then we have the millimeter wave, which is the band from 24 to 100 gigahertz. So in this presentation, I'm going to present it in two parts. I will start first with the sub-gigahertz antennas and measurement capabilities, and then we will look at the millimeter wave. So we look more in detail into the frequency ranges. Below 1 gigahertz are the typical applications for the massive Internet of Things, because at those frequencies you will have longer range. Between 1 and 6 gigahertz, there will be mostly the wider bandwidth and low latency applications, like the for mission critical. And then in millimeter wave, they are focused on the extremely wide bandwidth, shorter range, and very high capacity. So the 5G deployment is a reality. It's estimated that 90% of the 5G sales in the emerging markets is going to be covered by sub-gigahertz band by 2026. So we saw before that we could have 5G either at sub-gigahertz or millimeter wave. According to this AV research, most of the deployment will be done first in the sub-gigahertz, and there are two reasons. One of them is because the shorter range, so a millimeter wave, of course, you have very short range, so you will need more devices to have longer coverage, and then the higher cost of the deployment. So this is why it's delaying this deployment. So most of the deployment of 5G will be in the sub-gigahertz. And as I was saying, these are realities. So here is an example of our partner, Deutsche Telekom, where you can see all the countries and of Deutsche Telekom and their partners that already with commercially available 5G. And on the left side, you can see the bands. So the black bands, the ones in black are the 4G bands. The ones in pink are the 5G bands. They receive this coexistence and dual connectivity. And you can see the new bands, the N78 is the new bands for sub-gigahertz that are using for only 5G. So if you want, I don't have the details here about what bands in each region, but if you want more details, I can contact you with the right person for this information. So now let's start, before we start talking about antennas, let's look at the modules, what is available now in the market in terms of 5G. So there are several module makers who have in the market 5G radio modules. Most of them, the majority, are using M.2 cards. So the M.2 card is similar to the example that we are showing here from Sierra Wireless, where you see this kind of connection of the card with the module in, and all antennas are connected and are off board. There will be some receptacles on the board. So for the sub-gigahertz, the modules have 4x4 antennas, and they are using MHF4 receptacles. On the millimeter wave side, the number of antenna changes could be 4x4 or 12x12 or some other numbers of MIMO, and they're using special connectors, MHF47S, MLC, or some other type of receptacles which are using some intermediate frequency. So when we are looking at the antenna size, so we can look at the specifications from the radio modules, and not all of them have the same configuration. So here we are seeing an example where from Sierra Wireless, where they have the 4 antennas. You have the main, the aux antenna, and MIMO 1, MIMO 2. And if you realize, not all antennas are covering the same band. So the main antenna is covering all the low bands and high bands and the 5G, while the MIMO is only covering the mid-band, high band, and ultra-high band plus M41. MIMO 2 is covering M2, middle band, high band, and ultra-high band, and the L5 or GNSS. So it's also the GNSS antenna is also covered by one of the MIMO 5G antennas. And the auxiliary antenna is covering low band, mid band, and also the L1 of the GNSS. So each antenna has different configurations. So one solution would be to have antenna covering all the bands, but depending the size of your device, it might create issues with the isolation. So this is something we need to identify when we are looking at the antenna system, and is to see what are the frequency bands covered by each antenna port. And then we can help you optimize the system so you can have the better coexistence with all antennas. So if we look at today in sub-gigahertz antenna solutions, why I mean today? Because Today in the market, we saw that most of the module makers are using M2 cards, and all of them have receptacles. So that means that the logical approach for our customers is to use off-board antennas or external antennas. For the off-board antennas, the antennas will all be available with the MHF4 connector, so you can connect directly on the M2 card. Here as an example, we have standard solutions like first antenna 1,053,92 at 0, where actually this antenna is a dual fit. So you have one of the cables will connect to all the frequency 5G bands from 600 megahertz, 5 gigahertz. And then the other cable will connect will transmit the Wi-Fi dual band frequency bands. You can have Wi-Fi and 5G included. We have another antenna which covers 600 megahertz also to 5 gigas with the cable on the side, another antenna with a cable in the middle. So we base our standard products to help our customers to have available options off the shelf through our distributor. So this is where we are working, and we are very focused on our customer needs. So if there's something that you are missing that you don't see in our portfolio, we are always open to create new products to our customers. These antennas are designed to be ground independent, because when you have embedded antennas, it can affect a lot the size of the device. In this case, these antennas are prepared to be able to be ground independent, to have good performance wherever you are placing them in your device. Then, as we said before, there are some ports where you don't need to cover all the bands from 600 megahertz to 5 gigas. Actually, this will be an issue in terms of space, isolation between antennas. This is why we have new families coming covering only the high bands of the antenna from 2.1 to 5 gigahertz. Also, some of them will be covering the L2 GNSS bands, as, for example, for the Sierra Wireless module. And in some cases, our customers, they are asking for higher gain antennas for CPE, which is custom premises equipment. So this is also another option we have. So as I said, we are very driven for the customer needs to be able to offer as fast as possible solution. When we look at the external, we have blade antennas that cover all the frequency bands. We have different types of antennas that can be placed with a magnet, with adhesive. Here in this example, we are showing an antenna that is covering 4x4 MIMO for 5G, LTE 5G, Wi-Fi dual band, 2x2 MIMO, V2X, and GNSS. The reason why we are featuring this antenna is that it's 8-in-1 antenna, but actually is designed to be over the ground. So many times there is the need to have antennas placed over the metal, which is normally not the ideal condition for base antenna radiation. So we have this design that we have designed over ground plane. So this is something that is already tested in the worst condition. And for all external antennas, the typical connection is not the MHF4 that is needed. So of course we have adapters or cables, accessories that you can connect from SMA or FSMA to MHF4 and different combinations. So now if we look at the future, what is going to come? So there are two things here. Most probably the modules will be already available on board, so you don't have this extra card, so you will be able to design directly the transmission line or your main board, and so we will be able to implement the antennas SMT solutions, which are cheaper, it's faster to implement because you can have pick and place, and for that we have already solutions available that goes from 600, we cover the high bands, antennas which only cover the high bands, and we will continue increasing the family as the needs we were discussing before. And then, of course, we have the option of custom design, because we know that not always we have a space for a standard product. And in Kyocera IVF, we have extensive manufacturing capabilities where we can shape the antenna in very small device, in very small volumes. We have the technology, for example, LDS, which means laser direct structuring, where we can print the antenna directly on the plastic with a laser. we have the single one. We also have a technology for multi-layer LDS, which is proprietary from us. And then, of course, all the other typical technologies like two-shot injection molding, over-molding, flexible PCB, stamping, and so on. So we have 3 factories worldwide in Korea, China, and Vietnam to support this manufacturing. In terms of capabilities, we have design centers all around the world. 5 design centers with fully equipped with measurement capabilities and prototyping capabilities. Here are some examples of measurement systems, like we have a SAR measurement systems, we have anechoic chambers, automotive chamber. We can, especially for autonomous driving, it's very useful for us to measure not only the antennas on the car, but also inside the car, which is when you know what's going to happen with all the metal around and how much radiation you are really transmitting. And we are going to upgrade our measurement systems to the 5G technology, so be able to measure the TRP and TIS, and this will be available in 2022. Currently, we have capabilities to measure low power one, so narrowband IoT, LTM. We have the capabilities to measure actively those technologies. The 5G will be available in 2022. Now, if we look at the millimeter wave, so the millimeter wave is a completely different structure compared to the sub-6 gigahertz. Normally, they are made of arrays. And you can, dependent, of course, you can have arrays of 4x4 or with different combinations. You can see here some high-gain antenna designs, a prototype and simulations. We can have also larger arrays, and this is with 8 and 16 antennas. And of course, we design also all the beamforming capabilities with the different phases. And the frequencies we can vary. It can be from 24 to 30. You can have a 28 gigahertz, et cetera, et cetera. So we were looking at the planar antennas array, which is what mostly is used in millimeter wave. So what is in the future? So in the future, as we said, we don't only have the full space to have a big planar array. Especially, we are talking about handheld devices. This is why we are having a lot of investment in R&D to overcome this situation. How we are going to design these antenna arrays, but in the real devices, like for example, cell phones. So one of the things from the technical point of view, from the antenna performance point of view, is that we cannot anymore have one single array. So imagine if you have your cell phone and you have an array of antennas, and then you cover it with your hand. It will be over at those frequencies. You won't have any. You will have the body absorption. You will have. You will reduce the directivity. So this is why most of the times in these cases you will need an array of arrays. So that's one of the differences. And also we need to consider that, as I mentioned before, the cost of these higher frequencies is very high. So we are doing a lot of research about low-cost manufacturing technologies that are now in our factories, how we can use those technologies at higher frequency. Of course, at higher frequency, you have higher losses, and there's more difficult accuracy. So it's very important that we manage to find this trade-off between having the performance that is required at those higher frequencies, and at the same time having the cost that is not as high as the current solutions. So this is the future of the respect for the millimeter wave. In terms of the measurement capabilities, we have designed our own millimeter wave chamber. So this millimeter wave chamber is for the range between 18 gigahertz to 110 gigahertz. It can do all the type of measurements for small devices up to the size of a laptop. Measure the gain, the activity, efficiency, bandwidth, cross-pulse discrimination, etc. And then we can also do the measurements for the TRP and TIS, the active testing. And it's actually a product that we are selling. So as we said, we expect that there will be more and more need of testing because of the in handheld devices for the millimeter wave technology in small devices, because the hands, the location will be affecting. So there will be more and more testing compared to the 4G. So many of our customers require to have these 5G millimeter chambers on their lab to be able to do quick testing. So this is a product that's called ETH MNW1000, and it's available with our distributor Richards. At the same time, we, of course, you don't need to, if you need the measurements, you don't need to purchase directly the chamber, but you can also use our testing services. So these are the part numbers of the testing we are offering for millimeter wave. And again, this can be ordered through our distributor. We have, for example, millimeter MMWTS001, where it's a testing of the passive testing on a fixed array configuration. We can do the testing also, the passive antenna in beamforming array configuration, with signaling, without signaling, and sometimes even the renting of the chamber is possible. So depending on this, you can ask for a quote, and we can offer you these services. And finally, the conclusion is that the 5G, in order we become a reality by having the massive Internet of Things, instantaneous response time, and ultra high speed. And for all of that to be able to have a successful rollout, it's very important to look at antenna systems. So we are here to help you, and we will be very happy also to hear about your needs, your future plans, and so either with our standard solutions or our capabilities, we can help you design new things. Thank you very much, and I pass to you, Katie, and see if there's any questions.
Great, Carmen, thank you so much for that great presentation. As you mentioned, we are going to start taking some questions from our audience. So to our audience, if you do have a question for Carmen today, go ahead and place it into the Q&A window and click submit. We're going to do our best to get through as many questions as we can. If we do not have time for your question today, we will reach out to you following today's webinar. So Carmen, the first one today, what are the typical gain values for the millimeter wave antennas shown in the presentation?
Okay, so I believe we are talking about this slide. So yeah, so the gain of the antennas in arrays, of course, depends on the number of elements we have. So in this example, on the left side, we have an array of 4x4, and this the gain of this antenna is 8 dBi. So it's actually a dual polarized array in that case. So we have two polarizations per patch in there. Then the array on the left side, on the right side, it's as it says there is 8x16. So of course it has much higher gain, and the gain is around 25.5 dBi in that case.
Okay, Carmen, thank you so much for that answer. Another question here. Does Kyocera AVX have capabilities for manufacturing high reliability antenna products for mission critical applications?
Could you repeat the question, please?
Sure. So the question is asking, does Kyocera AVX have capabilities for manufacturing high reliability antenna products for mission critical applications?
Yeah. Okay. Thanks. Yes. So we do have capabilities to measure, to manufacture high reliability products. As I mentioned, we have factories in China, Vietnam, and Korea, and we do have products especially for military. I would say that's the main industry that we are covering for high reliability. Most of our designs are custom-based, customer base, and we do custom designs for our customers, but we do have a capability, yes.
Okay, thank you so much for that answer. As I mentioned before, if you have a question, place it into the Q&A window and click submit. If we don't get to your question, please do not worry. We will respond to you following today's webinar. So our next one here, for which 5G applications is Kyocera AVX already shipping production antenna solutions?
So right now, the only 5G products we are shipping, and it's right now in the market, are for cell phones. So the cell phone designs, many of the 5G cell phones, especially for Samsung, has our antennas inside. We have many other products, projects in design stage, mostly in IoT, industrial routers, CPEs, but they are not still in the production phase.
Okay, great. Thank you so much for that answer. Okay, another attendee is asking, can Kyocera AVX help me develop a custom 5G antenna solution for my requirements?
Yes, we have the capabilities. So we have design centers in the US, in San Diego, in Europe, in France. Then we have in Asia, we have in Korea, Taiwan, and China. So all the design centers, they have design and testing capabilities, and we will be able to adjust to the requirements of our customers and make fully customized designs. Mm-hmm.
All right, Carmen, thank you so much for that answer. Another attendee is asking, I would like to confirm if frequency selection is based on 5G chip requirements or system design.
Yes, so if I understand correctly the question, it was asking if the selection of the antenna is based on the chipset, I believe. Yes, in that case, yes. It's, as I mentioned before, for example, depending of the module maker, they have different antenna outputs. So some outputs will have the GNSS together with the 5G or 4G antenna. In other cases, there will be the GPS antenna separately and only covers the 4G and 5G. In those cases, sometimes you have the main and aux covering low and mid-high bands, while the other two MIMO antennas, the higher bands only. And some cases also a different combination. So it's very important to see what is the module they are working on, and to adjust the antenna requirements into that module.
Carmen, thank you so much for that answer. All right, another attendee here. Does Kyocera AVX have the ability to test in an anechoic chamber?
Yes, so we have anechoic chambers in all our design centers. So we have different chambers. As I was showing before, maybe I can go to this slide. So we have different types of automotive. We have the automotive chamber for large devices. Actually, we don't only measure for automotive, but also for big devices like fridges or washing machines. We have measured there, actually. Then all the anechoic chambers between 600 megahertz to 6 gigahertz, and then the millimeter waves that goes up to 110 gigahertz.
Okay, Carmen, thank you for that answer. Reminder to our attendees, if you have a question today, go ahead and place it into the QA window and click submit. All right, a next one here. For 5G, are multiple antennas used for, I think there's a mistype here, but I'm going to guess 6 gigahertz bands, or only sub 6 gigahertz bands?
I'm not sure I understand. Could you repeat the question?
Sure. For 5G, are multiple antennas used for, like I said, there's a mistype here, but 6 gigahertz bands or only sub-6 gigahertz bands? And we can always answer this following the webinar, Carmen, if you need to.
Yeah. So yeah, I mean, MIMO is used in all the cases. So you have MIMO is used for the sub-gigahertz, and then for, I don't know if they mean for the millimeter wave, if they are using MIMO. I don't know. Maybe they can write the question. Not clear.
Sure, no problem. So maybe if that person would like to write in and clarify a little, or we can get back to you following the webinar today. So our next question here. Okay, so they did write back in. So follow up to the question we just asked. I meant above 6 gigahertz bands or only sub 6 gigahertz.
Okay. So yeah, for sub-gigahertz, for sure it's the MIMO. For the millimeter wave, as we saw, I will need to come back to see exactly if it's really MIMO, because we are doing the beamforming with an array. But I will come back to you with the answer for that question. Because I know that we are, for example, in the user device, we can have different arrays of antennas. But normally the current solution, I know that is only one array of antennas. And then, yeah, I believe it's MIMO because it's like 4 times 4 and 6 times 6. But I prefer to double check and come back with this answer.
All right, Carmen, thank you so much. So we'll get back to that attendee following today's webinar with an answer. So we'll move on to the next one here. Are 5G millimeter wave array sample evaluation boards available?
So we have some millimeter wave samples for 5G millimeter wave array samples that we use. Normally, we use them for reference testing in our chambers. It's not available in the way to provide to customers because it really depends of the module they are using. You know, the number, the range of the gain they need, and so it's really difficult to provide samples like that. It depends on the module they are using and other considerations. So we do have samples that we use as own reference for measurement, but it's not samples that the customers can use themselves. They will have to give us the requirement to be able to give them the array they need.
Okay, Carmen, thank you so much for that answer. As I mentioned to our attendees, if you have any questions today, go ahead and place it into the Q&A window and click submit. This webinar will be available following today's session for the next 90 days. So if you did have a question that you wanted to ask or thought of something after today's webinar, feel free to come back in and submit your question during our on-demand period. So, Carmen, I think there's about 1 or 2 more left that we're going to take today. As I mentioned, if we didn't take your question today, we will reach out to you following the webinar. So we'll take these last couple, unless anybody has any more that are going to be submitted in a minute. But this will be our last set, Carmen, if no one else submits anything. So this last person is asking, do you have the PCB antennas that can be used for, and we're going back to the MIMO, 5G 2500-2700 megahertz and 3300 to 3800 megahertz. He would like to be able to create a dual polarization and array of 8 times 1. And then there's a kind of a follow-up to that saying that it would increase the array size from 8 times 1 to 8 times 8.
Yes, so I'm going to go back to this slide where you can see that we do have solutions. We have in metal stamping and some others that are also based on FR4 that can cover those bands. But depending on the requirements of the MIMO you would like to do, it's possible that we can give in the size of her, the size needed. But yeah, we have some solutions already to cover only those bands.
Okay, Carmen, thank you so much for answering that last person's set of questions. So we are going to start to wrap the webinar up right now. If anybody has any questions for Carmen that they think of following today's webinar, as I mentioned, you can submit them during the on-demand period, so feel free to come back and watch this again and submit any questions that you can think of. If we didn't answer your question today, we will reach out to you following the webinar. So Carmen, I want to say a huge thank you to you for giving such a great presentation and for answering some of our attendees' questions today. So thank you so much.
Thank you very much, Katie, and thank you, everyone. And don't hesitate to send more questions, and we'll be happy to contact you back.